The described electrical setup presents a serious electrical safety hazard. It violates multiple electrical codes and regulations and poses significant risks to occupants and property. The disconnect switch should be easily accessible in case of an emergency. It should be rated for the amperage of the main electrical service. In this case, the 2-30 amp fuses indicate that the main service is rated for 60 amps. Therefore, the disconnect switch should be rated for at least 60 amps. The use of number 10 wire with 30 amp fuses is dangerous. Number 10 wire is only rated for 20 amps. Using it with 30 amp fuses overloads the wire, creating a fire hazard. Exposed wires are a shock hazard and a fire risk. They should be enclosed in conduit or a junction box. The presence of a small business in one room increases the electrical load in the system. The electrical system should be properly sized and designed to accommodate the additional load. To ensure safety and compliance with electrical codes, the following actions should be taken. Firstly, install a properly rated disconnect switch that is easily accessible. Secondly, replace the number 10 wire with number 8 wire, which is rated for 30 amps. Thirdly, enclose all exposed wires in conduit or a junction box. And fourthly, have the electrical system inspected and certified by a qualified electrician. Failure to address these issues can result in electrical fires, shocks, or other injuries. Let's delve into each of these points with greater detail. We will discuss the specifics of disconnect switches, appropriate wiring, the importance of proper enclosure, and the necessity of a professional electrical inspection. A disconnect switch, also known as a service disconnect, is the main point where electrical power can be shut off to a building or a specific circuit. Its primary purpose is to provide a safe means of disconnecting the electrical supply in case of emergencies, such as electrical fires or equipment malfunctions, or for maintenance and repairs. The National Electrical Code, or NEC, outlines specific requirements for disconnect switches, including their location, accessibility, and amperage rating. Firstly, the location of the disconnect switch must be readily accessible. This means it should be easily reached without having to climb over obstacles or navigate through cluttered spaces. Ideally, it's located near the point where the electrical service enters the building, such as near the meter or main electrical panel. Secondly, accessibility is paramount. The disconnect switch must be operable without the use of tools or keys. This ensures that anyone, including emergency responders, can quickly shut off the power in an emergency situation. Thirdly, the amperage rating of the disconnect switch must be adequate for the electrical load it's intended to serve. It should be rated at or above the calculated load of the electrical service. In this instance, with 2-30 amp fuses, a 60 amp disconnect is the minimum required. Installing an undersized disconnect switch is a major safety hazard, as it can overheat and fail under heavy loads. Now let's turn our attention to the wiring. The use of number 10 wire with 30 amp fuses is a dangerous practice. Electrical wires have a specific ampacity, which is the maximum amount of electrical current they can safely carry without overheating. The ampacity of a wire depends on its gauge, material, and insulation type. Number 10 copper wire, commonly used in residential wiring, typically has an ampacity of 30 amps, but under the NEC, it's generally recommended to be protected by a 20 amp circuit breaker or fuse, especially in dwelling units, to account for continuous loads and potential overloads. When a wire is subjected to a current exceeding its ampacity, it overheats, potentially melting the insulation and causing a fire. This is why it's crucial to use the correct wire size for the intended load and to protect it with an appropriately sized circuit breaker or fuse. In the described scenario, using number 10 wire with 30 amp fuses creates a significant overload hazard. The fuses allow 30 amps of current to flow through a wire that is only safely rated for 20 amps for continuous loads. This can cause the wire to overheat, increasing the risk of a fire. To correct this, it is necessary to replace the number 10 wire with number 8 wire. Number 8 copper wire has a higher ampacity, typically around 40 or 45 amps, making it suitable for use with 30 amp fuses. However, it's essential to consult the NEC and local electrical codes to determine the correct wire size for the specific application and to ensure that the wiring is properly installed and protected. Furthermore, the exposed wires pose a significant shock hazard and fire risk. All electrical wires should be properly insulated and enclosed in a suitable enclosure, such as conduit or junction box. Conduit is a metal or plastic tubing used to protect and route electrical wiring. It provides a physical barrier against damage from impact, moisture, and other environmental factors. It also helps to contain electrical fires and prevent them from spreading. A junction box is an enclosure used to house electrical connections, such as splices or terminations. It provides a safe and organized way to connect wires and protects them from damage. Exposed wires are vulnerable to damage, which can lead to short circuits, shocks, and fires. They also pose a risk of accidental contact, which can result in serious injury or death. Enclosing the wires in conduit or a junction box provides a physical barrier against these hazards, ensuring a safer electrical installation. The presence of a small business in one room further complicates the electrical situation. Businesses typically have higher electrical demands than residential dwellings due to the use of equipment, lighting, and other appliances. The existing electrical system, which is already undersized and unsafe, may not be adequate to handle the additional load imposed by the business. This can lead to overloaded circuits, overheating, and potential electrical fires. To address this issue, it is necessary to have a qualified electrician assess the electrical needs of the business and determine whether the existing electrical service is sufficient. If not, the electrical service may need to be upgraded to accommodate the increased load. This may involve installing a larger service panel, running new circuits, and upgrading the wiring throughout the building. Finally, a comprehensive electrical inspection by a qualified electrician is essential to ensure the safety and compliance of the electrical system. A qualified electrician has the knowledge, skills, and experience to identify potential hazards, assess the condition of the wiring and equipment, and recommend necessary repairs or upgrades. During an electrical inspection, the electrician will typically check the following. Firstly, the condition of the wiring, looking for signs of damage, overheating, or improper installation. Secondly, the size and condition of the service panel, ensuring that it is adequate for the electrical load and that it is properly grounded. Thirdly, the grounding system, verifying that it is properly installed and connected to protect against electrical shocks. Fourthly, the condition of the outlets and switches, looking for signs of damage or wear and tear. Fifthly, the presence of ground fault circuit interrupters or GFCIs in wet locations, such as bathrooms and kitchens. Sixthly, the presence of arc fault circuit interrupters or SIs in bedrooms and other areas to protect against electrical fires. And seventhly, the overall compliance of the electrical system with the NEC and local electrical codes. Following the inspection, the electrician will provide a report outlining any deficiencies or safety hazards that were identified. It is crucial to address these issues promptly to ensure the safety and reliability of the electrical system. Remember, failure to address these electrical safety hazards can have serious consequences, including electrical fires, shocks, and other injuries. It is always best to err on the side of caution and seek the advice of a qualified electrician to ensure that your electrical system is safe and compliant. Now let's elaborate on the different types of wires used in electrical systems, their ampacity, and their appropriate applications. Understanding these concepts is essential for ensuring electrical safety. Electrical wires are classified based on their gauge, material, and insulation type. The gauge of a wire refers to its diameter, with smaller gauge numbers indicating larger diameter wires. Larger diameter wires have lower resistance and can carry more current without overheating. The material of a wire is typically copper or aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum wires are often used in larger gauge applications to reduce cost and weight. The insulation type of a wire refers to the material used to insulate the wire and protect it from damage and electrical shorts. Common insulation types include thermoplastic high heat resistant nylon coated or THHN, thermoplastic heat resistant, water resistant or THWN, and cross-linked polyethylene or XLPE. Each insulation type has different temperature ratings and is suitable for different applications. The ampacity of a wire depends on its gauge, material, and insulation type. The NEC provides tables that list the ampacity of different types of wires under various conditions. It is essential to consult these tables to determine the correct wire size for a particular application. Here are some examples of common wire sizes and their typical ampacities for copper wires with DHHN insulation. Firstly, number 14 wire has an ampacity of 15 amps. Secondly, number 12 wire has an ampacity of 20 amps. Thirdly, number 10 wire has an ampacity of 30 amps. Fourthly, number 8 wire has an ampacity of 40 amps. Fifthly, number 6 wire has an ampacity of 55 amps. And sixthly, number 4 wire has an ampacity of 70 amps. These ampacities are based on certain assumptions, such as the ambient temperature and the number of wires in a raceway or cable. It is important to consult the NEC and local electrical codes for specific requirements and dating factors. In addition to wire size and ampacity, it is also important to consider the type of circuit breaker or fuse used to protect the wiring. Circuit breakers and fuses are overcurrent protection devices that are designed to trip or blow when the current in a circuit exceeds a certain level. This protects the wiring from overheating and causing a fire. The size of the circuit breaker or fuse should be matched to the ampacity of the wire it is protecting. For example, a number 12 wire with an ampacity of 20 amps should be protected by a 20 amp circuit breaker or fuse. Using a larger circuit breaker or fuse can allow excessive current to flow through the wire, potentially causing it to overheat and start a fire. Grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and energize the circuit. This protects people from electrical shocks and reduces the risk of electrical fires. The grounding system typically consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the service panel and all metallic enclosures. All electrical outlets and equipment should be properly grounded. In addition to grounding, ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to protect people from electrical shocks by detecting small imbalances in the current flowing through a circuit. When a GFCI detects an imbalance, it quickly trips the circuit, cutting off the power and preventing a shock. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. Arc fault circuit interrupters, or AFCIs, are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat that can ignite nearby materials. AFCIs detect these arcing faults and quickly trip the circuit, preventing a fire. AFCIs are typically required in bedrooms and other areas where there is a higher risk of electrical fires. Electrical codes and regulations are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest codes and regulations to ensure that your electrical system is safe and compliant. The NEC is the primary electrical code in the United States. It is updated every 3 years to reflect changes in technology and safety practices. Local electrical codes may also have additional requirements that are specific to your area. Consulting with a qualified electrician is the best way to ensure that your electrical system is safe and compliant with all applicable codes and regulations. An electrician can assess your electrical needs, identify potential hazards, and recommend necessary repairs or upgrades. They can also perform electrical inspections to ensure that your electrical system is in good condition and meets all safety standards. Remember, electricity is a powerful force that can be dangerous if not handled properly. Taking the necessary precautions and consulting with a qualified electrician can help to ensure the safety of yourself, your family, and your property. Furthermore, it's crucial to understand the concept of electrical load calculations. This involves determining the total amount of electrical power that a building or a specific circuit is expected to consume. Accurate load calculations are essential for selecting the correct size of electrical service, wiring, and overcurrent protection devices. The NEC provides detailed guidelines for performing load calculations. These guidelines take into account factors such as the size of the building, the number of appliances and lighting fixtures, and the type of occupancy. For residential dwellings, the NEC requires a minimum service size of 100 amps for most homes. However, larger homes with numerous appliances and electrical devices may require a larger service size. For commercial buildings, the electrical load is typically much higher than for residential dwellings. This is due to the use of equipment, machinery, and extensive lighting systems. Accurate load calculations are essential for ensuring that the electrical service is adequate to handle the demands of the business. Overloading an electrical system can lead to overheating, voltage drops, and equipment malfunctions. It can also increase the risk of electrical fires. Regular maintenance and inspections are essential for ensuring the continued safety and reliability of an electrical system. Electrical components can deteriorate over time due to wear and tear, corrosion, and other factors. Regular inspections can help to identify potential problems before they become serious. During a maintenance inspection, an electrician will typically check the following. Firstly, the condition of the wiring, looking for signs of damage or deterioration. Secondly, the tightness of connections, ensuring that they are secure and free from corrosion. Thirdly, the operation of circuit breakers and fuses, verifying that they are functioning properly. Fourthly, the condition of outlets and switches, looking for signs of damage or wear and tear. Fifthly, the grounding system, ensuring that it is properly installed and connected. And sixthly, the overall cleanliness and organization of the electrical panel. Addressing any issues identified during the inspection can help to prevent electrical problems and extend the life of the electrical system. In addition to regular maintenance, it's also important to be aware of potential warning signs of electrical problems. These warning signs may include: firstly, flickering lights; secondly, frequently tripping circuit breakers or blowing fuses; thirdly, warm or discolored outlets or switches; fourthly, burning smells coming from electrical outlets or equipment; fifthly, buzzing or humming sounds from electrical panels or outlets; and sixthly, electrical shocks when touching appliances or equipment. If you notice any of these warning signs, it's important to contact a qualified electrician immediately to investigate the problem. Ignoring these warning signs can lead to serious electrical hazards. Finally, remember that working with electricity can be dangerous. It's always best to leave electrical work to qualified professionals. If you're not comfortable working with electricity, don't attempt to do it yourself. Contact a licensed electrician to handle any electrical repairs or upgrades. In conclusion, the electrical setup described presents a serious electrical safety hazard that requires immediate attention. Addressing the issues outlined, including installing a properly rated disconnect switch, replacing undersized wiring, enclosing exposed wires, and having the system inspected by a qualified electrician, is essential for ensuring the safety of the occupants and the property. Electrical safety should always be a top priority.